Observability and SRE Part 10. This episode has 14 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. LLM app operations. How would you operate an LLM-backed service in production, including latency, cost, prompt changes, safety, and observability? Here's a strong way to approach it. Monitor latency, time to first token and total generation time separately, cost per request or user, and treat prompt changes with the same rigor as code changes, versioned, tested, and rolled out gradually. Layer in safety checks, input or output filtering for harmful content, PI redaction, as a non-bypassable part of the request path, and instrument tracing that captures the full request, retrieved context, prompt, model version, response, so any bad output can be debugged after the fact. Nice. Let's continue. Question 2. FinOps showback. How would you implement cost allocation, labels, budgets, showback, and team accountability across GCP projects? Here's a strong way to approach it. Enforce required labels, team, cost center, environment via org policy so cost can be attributed accurately. Set budgets with alerting thresholds per project or team so overspend is caught early rather than at month end. And publish a regular showback report so each team sees their own spend trend without necessarily charging it back financially at first. Move from showback to real chargeback once teams trust the attribution accuracy and have had time to adjust behavior. Great. Moving on. Question 3. Incident behavioral. Tell me about a time you disagreed with developers during a production incident. How did you handle it? Here's a strong way to approach it. Structure this as a specific story. Describe the disagreement, e.g. over whether to roll back versus continue debugging live. Explain how you made the case for your position using data or risk reasoning rather than authority. And describe how the disagreement was resolved, ideally showing you prioritized user impact and incident resolution speed over being right, and that you followed up afterward to align on the decision framework for next time. Alright, next question. Question 4. Leadership behavioral. How would you mentor junior engineers on Kubernetes troubleshooting and Terraform safety? Here's a strong way to approach it. Pair on real incidents and change reviews rather than only lecturing. Walk through your own debugging process out loud so the reasoning, not just the command, transfers, and give juniors low risk but real production troubleshooting opportunities with you as a safety net. For Terraform safety specifically, enforce the habit of always reading the plan output before approving an apply, and use post-mistake moments as teaching opportunities rather than blame, since that's when the lesson lands hardest. Let's keep going. Question 5. Design trade-off. When would you intentionally choose a simpler architecture over a highly available multi-region design? Here's a strong way to approach it. Choose simplicity when the service's actual availability requirement doesn't justify multi-region complexity and cost. An internal tool with a few hours of acceptable downtime a year doesn't need active multi-region. Multi-region adds real operational cost, data consistency complexity, failover testing burden, higher baseline spend, so the decision should be driven by the actual business law and cost of downtime, not a default assumption that more resilience is always better. On to the next one. Question 6. Communication. Explain a complex GKE outage to a non-technical product leader in 2 minutes. Here's a strong way to approach it. Lead with impact and status, not mechanism. What broke? Who was affected? For how long? And what's the current state? Fixed, mitigated, ongoing. Use a plain language analogy for the technical cause only if it helps understanding, e.g. a routing update caused traffic to be sent to servers that weren't ready yet. Skip Kubernetes-specific terminology entirely, and close with what's being done to prevent recurrence and when a full write-up will be available. Good. Here's another one. Question 7. Drift monitoring. In production, how would you detect data drift, concept drift, and schema drift, and how would each one trigger different actions? Here's a strong way to approach it. Data drift, input distribution shifting, is detected by comparing feature statistics against a training baseline using tests like Population Stability Index. Concept drift, the relationship between inputs and target changing, Shows up as accuracy degradation on labeled feedback data even if inputs look stable. Schema drift. Fields changing type, appearing, or disappearing, is caught by validating incoming data against an expected schema before it reaches the model. Data and schema drift typically trigger a pipeline alert and pause, while concept drift triggers a retraining evaluation, since it usually means the underlying real-world pattern has genuinely changed. Nice. Let's continue. Question 8. Model registry. How would you design model versioning, approval workflow, rollback, lineage, and auditability using MLflow registry or Vertex AI model registry? Here's a strong way to approach it. Register every trained model with its version, training data reference, code commit, and evaluation metrics attached as metadata, and gate promotion from staging to production stages behind an explicit approval, automated threshold check, human sign-off, or both, rather than direct registration. Keep prior production versions in the registry so rollback is pointing the serving endpoint at a previous version, and ensure lineage links every deployed model back to the exact training run and data that produced it for audit purposes. Great. Moving on. Question 9. Feature store. What production risks does a feature store solve, and how would you design feature freshness, parity, governance, and rollback? Here's a strong way to approach it. A feature store solves training or serving skew, features computed differently for training versus real-time inference and duplicated feature engineering logic across teams. Design freshness with defined SLAs per feature, batch updated daily versus streaming near real-time, and force parity by using the same feature computation code path for both training and serving. Add governance via feature ownership and access control since features often contain sensitive data, and support rollback by versioning feature definitions so a bad feature change can be reverted without breaking dependent models. Alright, next question. Question 10. Batch versus real-time inference. How would you choose between batch inference, real-time inference, asynchronous inference, and streaming inference for different business use cases? Here's a strong way to approach it. Use batch inference when predictions are needed on a schedule and latency doesn't matter. Nightly churn scoring. Real-time inference when a user is waiting for a response. Fraud check during checkout. Asynchronous inference when the request can be queued and the result delivered later. Document processing. And streaming inference when predictions need to update continuously as new events arrive. Real-time. Anomaly detection on a data stream. The choice drives very different infrastructure. Batch favors cost-efficient scheduled jobs. Real-time demands low latency always-on serving. Let's keep going. Question 11. A or B and Canary for ML. How would you run A or B testing or Canary deployment for an ML model while protecting users and measuring business impact? Here's a strong way to approach it. Start with a Canary, small percentage of traffic, to catch outright failures or latency regressions before wider exposure. Then run a proper A or B test with randomized, statistically sized cohorts to measure actual business impact, not just model accuracy against the incumbent model. Define the success metric and minimum sample size before starting to avoid peaking bias, and always have a kill switch to revert to the previous model immediately if the new model shows harmful behavior mid-test. On to the next one. Question 12. Model rollback. A newly deployed model has lower latency but worse business outcomes. How would you detect this and roll back safely? Here's a strong way to approach it. Detect it by monitoring business metrics, conversion, revenue, user engagement alongside technical metrics, not just latency and accuracy, since a model can be technically healthy while quietly hurting the business. Roll back by repointing the serving endpoint to the previous registered model version. This should be a fast, low-risk operation if the registry and deployment pipeline were designed for it, and investigate offline why the new model underperformed on business outcomes despite passing technical evaluation before attempting to redeploy it. Good. Here's another one. Question 13. Reproducible training. How would you make an ML training pipeline reproducible across code version, data version, features, environment, and model artifact? Here's a strong way to approach it. Pin the code version, git commit, data version, a version dataset snapshot or a query with a fixed timestamp, not a live table, the exact feature computation logic, and the training environment, containerized with pinned dependency versions for every run. Capture all of this as metadata alongside the resulting model artifact in the registry, so any past model version can be traced back to and, if needed, regenerated from the exact same inputs. Nice. Let's continue. Question 14. Metadata management. What metadata would you capture for every ML run to support audit, rollback, debugging, and compliance? Here's a strong way to approach it. Capture the code commit, data version or snapshot reference, hyperparameters, training environment, evaluation metrics, the person or pipeline that triggered the run, and the resulting model artifact's location and hash. This metadata is what makes rollback safe. Know exactly what you're rolling back to, debugging possible, reproduce the conditions that produced a bad model, and compliance auditable. Prove what data and code produced a decision-making model. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.